A client recently asked me if we could train AI on their products so that the AI could answer customer questions, which is a totally reasonable question, but it's based on a completely wrong mental model of how AI actually works. See, most business owners can use ChatGPT, but knowing where and how to integrate AI into their business operations is still this vague, mysterious thing. But vagueness has a cost. The opportunities for your business are there, but if you can't describe them, you can't see them. So in this video, I'm going to give you the 10 words that explains 90% of how every AI system for businesses actually works. And don't worry, this isn't going to be an abstract list of technical jargon. We're going to learn these words by building the exact thing that our client asked for, an AI-powered customer support agent, step by step. Now, to start the story, I'm going to tell you about this game that I love called Codenames. Now, the game involves taking a single word, like pumpkin, and trying to identify as many other words that are associated with that word as possible. So I might come up with pie, Halloween, orange, right? And now the type of AI that's behind our support agent fundamentally is just something that has gotten really good at this game. There's lots of different types of AI. Some are really good at identifying objects and images, some drive cars, others generate images or videos. But the type that we're interested in, and the one that's been at the forefront of this explosion in AI in recent years, is called a large language model. You've probably heard of it by the abbreviated form LLM. Now, what made them so popular and mainstream is that LLMs are general purpose. They produce text. And text is a very flexible medium that can be turned into everything from blog articles to computer code. Now, I said here they produce text, but it would be more fair to say that they predict it. See, when these big AI companies like OpenAI and Anthropic train one of their LLM models, they feed it snippets of real text from websites and books, and they have it guess at what word comes next. And then they tell the model how wrong that guess was. By doing this trillions of times, over and over again, the model is tuned to understand all the subtle relationships between words in a similar way that the human mind does. The result is that it sees a single word as a blend of its semantic properties. And this is very similar to the way we represent colors, as a unique blend of redness, blueness, or greenness. And in the case of color, you've got this sequence of 3 numbers that can together represent any color. It's the same concept for a word in a large language model, except that instead of 3 numbers, you have thousands, representing this vast array of meaning. Now, this list of numbers we call a vector, but we can think of it like a unique signature for that word. What we end up with then is a sort of AI brain that has this vast dictionary. And this makes it very easy for the model to find words that are similar, because all it has to do is some simple mathematical operation to find out how far one vector, one word signature, is from another one. The result of which is that we're able to feed some snippet of text, like a question, and the AI can recognize that snippet as a question containing certain concepts and meaning, and it predicts the next word that would come after that question. Then that next word that it guesses gets appended to the end of the original snippet, the original question. And that whole thing, your original prompt plus the new word, runs back through that prediction engine and it guesses again, producing the next word. And it repeats this over and over until it predicts that this is basically the end of the response. Now, this is great for our support assistant, except that by default, this LLM knows an awful lot about the rest of the world, but nothing about our business. We have the equivalent of a new hire. They're bright and eager, but they don't yet know how to actually do their job. In fact, they don't even know that they have a job. In AI speak, we'd say that they have an empty context window. Now, this context window is something that we have to fill up every time that we use the model with information about who we want this agent to be, and what we expect from them. If you've ever seen the movie 50 First Dates, there's this character, Lucy, who suffers from amnesia. Every morning she wakes up with no memory of the day before, no memory of her life really, and her boyfriend, whose name is Henry, his solution is to record a video for Lucy to watch every morning. And the video explains not only her condition, but it reintroduces Henry to her, it updates her on world events. So this video fills Lucy's context window, in a sense. Before that point, she's just a blank canvas. She doesn't know anything about her life. So we have to create this frame for an AI model, this lens, and it's through that lens that it views the world. And the most important tool that we have for this is called a system prompt. Now, this is something you've probably already used in a sense, without necessarily knowing what it was. Whenever you've given AI a role up front, like, I don't know, you are an expert at getting babies to sleep. Help. That is essentially a system prompt. It's just a kind of a system prompt that's invisible to the end user. Whenever we configure an AI, we have this system prompt input where we put these special instructions that our end users never see. So for our support assistant, this is where we'd tell it its job, its tone of voice, how and when to escalate to a human. Think of this like a summary of all the training that you'd give to a new hire in their first week. So our system prompt gives our AI a role to play. So great, we'll put this AI with the system prompt in front of a customer. And now the customer asks about our return policy, and our AI can confidently tell the customer all about it. There's just one problem. Everything that they've told the customer is totally false. Now, this phenomena that AIs give the wrong information is aptly named hallucination, and it's an ever-present problem. The underlying issue is that LLMs, they don't think like humans. They're just hungry to predict the next word. They don't have a great sense of, I don't know the answer, like humans do. But we can drastically reduce the risk of hallucinations by actually giving the AI model the information that it needs. So one solution you might be thinking is that, well, we could just stuff all of our help desk articles, things about our return policy, warranty coverage, etc., just right into that system prompt. But see, using AI models, it isn't free. The currency, so to speak, of LLMs is something called a token. And by bringing up tokens, I do have to admit that I was lying to you earlier when I said that LLMs predict the next word. In fact, they predict the next token, which might be a whole word, might be a chunk of a word, a punctuation mark. It might even be a number. As a rule of thumb, a token is usually about 3/4 of a word. Now, models charge you based on the amount of tokens that you consume, both the ones that you feed the model with, i.e. that context window we talked about, and the ones they spit back out. If you only have a few help desk articles, the cost is negligible. But when you have loads of articles, loads of content, it can get expensive because every time that your customer sends a new message to the assistant, we've got all this baggage being dragged behind it. But there's actually a much bigger problem with this approach, which is that just because you can stuff your context window full of all this business and product information, doesn't mean that the AI can follow it without getting confused. It's the equivalent of asking it to have 100 conversations back to back with potential job candidates and then trying to answer the question of who is the most qualified. What we ought to do is keep our help desk articles in some database and just let the AI search through them. There's just one problem with that approach. Searching traditional databases involves matching keywords, but our article is titled Refund Policy and talks about things like refunds and returns and exchanges. And so when the customer types, "Can I get my money back?" a keyword search comes up empty because the words money back don't actually appear anywhere in that article. Now, the solution to this is something called the vector database. And how it works is it takes in a bunch of data, like your help desk articles, and it converts them to a unique signature, just like we do with an LLM during training. Now, remember that this signature is just a long sequence of numbers that represents the meaning of, in this case, a help desk article. And that sequence of numbers is called a vector, hence vector database. Then when a customer asks, can I get my money back? The system looks in the vector database for help desk articles with vectors that are close to that of the customer's question, which in plain English means it will return semantically similar articles. Okay, so this is cool, but we want our support assistant to do more than just regurgitate company policy. We want it to be able to actually do stuff like process a refund all by itself. We need it, in other words, to become an agent. Now, to process a refund, it might need to look up the details of the customer's order in the database. It might need to check the support documentation for the most up-to-date policy info. Maybe it needs to ask some follow-up questions to the user. So this is more than just a chatbot now. This is an AI agent that can make decisions and act autonomously. Now, agents, in order to do stuff, must be given something that the industry has called tools. Now, personally, I love this concept. I think of some Neolithic hunter-gatherer being given a knife or a chainsaw and them instantly having these new capabilities. It's the same with an AI agent, although I probably wouldn't give an AI a chainsaw. The way it works, however, is this great deception where, yes, we tell the agent that it has all these tools that it can use, and we explain how it can use each one, but then we don't actually give them the tools to use itself. The agent actually just tells us, well, it tells our app, which is running in the background, hey, I've decided to use the search orders tool. And because we've told it how to use that tool, it also provides us with the search parameters, so the customer's name that it wants to search and the date range that it wants to search. It's essentially delegating the actual work of searching to our application, which does the actual computational work of looking in the database, doing the search. And when it's done, our app gives the information back to the AI, where it can then decide what to do with it. Maybe the agent decides to issue the refund if everything looks fine. Otherwise, it might decide to ask some more questions or even escalate to a human. Now, this escalation to a so-called meat puppet is what we call human in the loop. We have a whole video on it right over here, but in essence, it means we as the human interject ourselves into the AI agent's workflow, where it otherwise runs in a loop of deciding what to do, acting, processing the results. It now pulls us in at the critical decision point. This is something we may very well want to do for sensitive actions, like sending emails or processing refunds, things where we don't fully trust the AI to make the right decision every time. So we built the support bot. It's great at handling refunds and answering questions on our business, but what about letting customers actually shop our products through the AI itself? Problem is that our support bot, it actually is hosted on our website. It lives in our website. Customers still have to go there to shop. But these days, an increasingly popular option is actually to let customers browse and search for your products directly in their AI app of choice, ChatGPT or Claude or Gemini or whatever they use. And to make this possible, we're going to use something called an MCP. It stands for Model Context Protocol, which is probably the worst name of any other concept in this video, but all it is a virtual reception for our application that AI assistants can walk up to and ask for stuff. So Imagine a user asking ChatGPT to search for a certain type of product. If ChatGPT has access to our NCP, then it can walk up to our reception and ask to see products in a certain category or a certain price range. And our virtual receptionist, if you will, then goes out the back, searches the database, comes back with some products, and then hands them off to ChatGPT, who then shows them to the user. MCP is a really powerful medium that is still relatively new, but is starting to be used by many companies who want to let users interact with their service just by chatting to their favorite AI assistant. So, you now understand the 10 most important AI concepts, but you still might be wondering how specifically to implement those in your business. And if that's the case, I suggest you check out this video somewhere over here. See you in the next one.